Hello and welcome to Lecture 12. This is the lecture for week 9. We've only got another one lecture to go after this, and then we'll be going into review and taking questions about your assessment and so on and so forth. So there's not far to go. Today I'm going to be talking further about statistical analysis and focusing particularly on difference. As I identified in the last lecture, difference is a really important thing when it comes to marketing research. When we're analysing market segments, when we're trying to decide what a market segment is, who comprises that, we're really talking about segmenting a market, making it different, understanding why it's different from other markets. We're understanding why people are different and what their different preferences are, and that can help us target people's preferences and needs. Okay, so in this lecture, I'm going to talk about the two sort of key statistics that we use when we're thinking about differences. So we're talking about differences in percentages and differences in means, and thinking about the significance of those and how we can calculate those. The reading for this lecture is chapter 13. I've decided to take a bit of an overall approach to this lecture, slightly bigger picture. I'll talk a little bit about some of the analysis, but I think probably I'm worried that I might be getting into too much detail for people, that it might not be that easy to understand when I'm just lecturing like this. So we can talk through it in the tutorial. You can have a look at the textbook, and I'll just try to discuss it in slightly more overarching terms to hopefully provide you with a broader understanding of the concepts. Okay, so we're back still at step 10. We've sort of gone back into this to consolidate and further understand data analysis. As I mentioned before, the data analysis is actually a pretty exciting part of the research. It's the part where you can actually do lots of tests and explore things and try different things and see what works. If you've been really clever in how you've collected your data, you should have some really interesting data to analyse and draw some insight from. And so this is probably one of the funnest areas to do the data analysis. But there are some key rules and understandings that you need to have to make it effective in use in terms of management and marketing perspective. All right, so in the last lecture I discussed descriptive analysis and inferential analysis. This lecture I'm discussing difference analysis in terms of whether differences actually exist, how to determine that, and also the statistical significance of difference. The next lecture I'll talk about association analysis, which may be of assistance for you in assessment 3. Well, not just association analysis, probably all of these analysis lectures might be useful to you. Okay, right, so as I said, differences are important. Differences between groups of consumers are the fundamental building blocks of marketing research and understanding how to segment the market. So they are the basis. Differences between groups of consumers are the basis for market segmentation. And understanding differences is critical, particularly in terms of whether making decisions about what you want to invest in terms of products, and maybe what you might want to let go of as well, and also in terms of expanding your market. Differences need to be, though, to be of value to you in a marketing or a management sense. They need to be statistically significant. They need to be meaningful. They need to be stable, and by that I mean not changing. So we analyse this and we make some decisions on it, and it'll be different in a couple of months. That's not really very useful. So they need to be quite stable, the differences that you analyse, and they need to be actionable to be of benefit in a marketing research sense. Okay, so difference tests are used to compare means or percentages between different groups or samples, as I said. So means and percentages are the usual ways that you do that. Now, just a statistical note here, the t-test is usually the inference test used with a small sample size of less than 30. The z-test is a test that's usually used with a larger sample size, which is more than 30. 30 plus. Yep. So that's just a small note, and it's not that critical, but it's important if you're starting to think about what tests you want to use later on. So you can have a look in the textbook about that because it's discussed further. Okay, so thinking about differences in percentages is where we're going to go first. So difference between the percentages with two groups, independent samples treated as representing two potentially different populations. So if you have a sample and it's half male, half female, you've pretty much got two different populations within your sample, and you can actually compare percentages across those, or you can actually compare across two different samples as well. So you can do that either way. The null hypothesis indicates that there's no significant difference in the percentage score between the two groups. So that's the null hypothesis is usually the no action alternative. So that's the thing when there's no change, there's no difference. Okay, the alternative hypothesis indicates where there is difference, and that's usually denoted as H1 or HA. And that usually says there is a significant difference in the percentage score between the two groups. So when you're thinking about writing hypotheses, that's what you want to be thinking about. The null hypothesis is no difference, and the alternative hypothesis is a difference, a significant difference. For example, percentage of cake eaters between males and females, bike riders and non-bike riders, Labor voters and Green voters. So they're different types of things that you might find that's really interesting or important for some reason. Possibly not cake eaters, but you never know. Could go either way. So it's important to be able to, you can hypothesise that, for example, Labor voters and Green voters, in that case, you might want to say, the null hypothesis is that there is no significant difference in the percentage of cake eaters between Labor voters and Green voters. Your alternative hypothesis is that there is a significant difference in the percentage of cake eaters between Labor voters and Green voters. So I hope that makes sense. All right, so you see that there may be a difference. Maybe 60% of Labor voters eat cake and 62% of Green voters eat cake, and we go, oh, there is a difference, but I don't know if it's significant or not. So then you have to do some calculations. So this is how we calculate. The Z value indicates significance. All right, and this is the calculation for that. So P1 is the percentage in sample 1, P2 is the percentage in sample 2. So in that case, P1 might be the Labor voters, and that might be 60% minus P2, which is the 62%. So P1 minus 60 minus 62 divided by the standard error of the difference between the two percentages. That's not as straightforward. You then need to go and do another calculation to actually calculate that, to feed that into that formula. So to calculate the standard error of the difference between the two percentages, you need to use this calculation, which is the square root of percentage 1 times Q1. Now, just to remind you from our previous sampling lecture, Q1 is 100 minus P1, so it's the other half. So for example, in the Labor voters, 60%, so P1 would be 60% and Q1 would be 40%. In the Green voters, P2 was 62%, so Q2 would be 38%. Is that right? Yeah, 38% or whatever it is. Yeah, for the calculator in my head. And then you might have two different sample sizes. So the sample size of the Labor voters might be 400, so that would be N1 would be 400, and the Green voters might be 500, so N2 would be 500. So you can do the square root of that, calculate that, then feed that result into the bottom of the Z calculation. So that will give you a value. So what does that mean? What is the significant difference? Z value tells you how significant it is. If the Z value is outside 1.96 and minus 1.96, then it is a statistically significant difference, and you can accept there is a difference, H1, that there is a difference, right? Z value is between 1.96 and minus 1.96. There is no significance. So you accept that there is no difference, HO, your null hypothesis, and reject H1. And I'll just give you a note too, that SPSS doesn't perform tests for significance of the difference in percentages between two groups. You have to use the SPSS command frequencies to produce the percentages that you need to create that and do that calculation. All right, so using an example in page 357 of the textbook, we can actually plug in some figures. So is there a significant difference in the percentage of companies hiring students from college campuses between 2 years? You can read this properly. So this is just giving you the overview of it rather than the full details. Okay, so the null hypothesis is that there's no significant difference in the percentage of companies hiring students from college campuses between 2 years. The alternative hypothesis, H1, is that there is a significant difference in the percentage of companies hiring students from college campuses between those 2 years. Okay, so given the figures and statistics that we get from the textbook example, percentage 1 is 65%, percentage 2 is 40%. So 1 year it's first year it's 65 and the second year it's 40%. The sample size in the first year is 100 and in the second year it's 300. So you can plug those details into your formula, P1 equals 65, so 65 minus 40 over the square root of 65 times 35 over 100 plus 40 times 60 over 300. Okay, and it comes to 4.51. Okay, so the Z value is 4.51. That says that it's outside 1.96 and minus 1.96. Okay, which means it's a statistically significant difference. And so you can accept H1, that there is a significant difference between the percentage of companies hiring students from college campuses between the 2 years. Hopefully that makes sense. All right, so now means. So that's percentages done, right? We've discussed that. You understand the formula, hopefully, and that should all make sense. Now we're going to talk about the differences in means. Now there's a few different ways that you talk about differences in means. There's a few different calculations you can use. So the first one I'm going to talk about is differences in means between two groups. Okay, so like I said before, independent samples are treated as representing two potentially different populations. Okay, so same deal. The null hypothesis said there's no difference in the population mean. The alternative is that there is a significant difference in the population mean between the two groups. For example, preferences on a Likert scale between males and females. So this is so we can get an average score. So it might be on a score of 1 to 10. Who likes, I don't know, what your opinion of Malcolm Turnbull, the current Prime Minister, is. What is your preference of that? What's your mean preference of him as a person? I don't think that's a very good example, but you know, so it's a preference rating from 1 to 10 or 1 to 5 or whatever, and that can give you a mean score for different groups. So, for example, if we go to the Labor voters and the Green voters, the Labor voters might hate Malcolm Turnbull more, so their average rating of him might be down at 2, but the Green voters might think he's better than the Labor alternative, so they might vote him at 3, you know, as an average. So that's your average rating from those two groups that you can compare. So is the difference between those statistically significant? Okay, again, same deal, very, very similar formula. X1, so X is the mean, Z is the significance. It's the same figures too, 1.96. Okay, so X1 is the mean in sample 1, X2 is the mean in sample 2, and the standard error of the difference between the two means calculated differently, whereas where you have standard deviation in sample 1, standard deviation in sample 2, the size of sample 1, the size of sample 2, in that formula, and then that plugs into the bottom of the Z formula. So that's how you calculate it. And yet again, if the Z value is outside 1.96, it's statistically significant and you can accept H1. If it's between 1.96 and negative 1.96, there's no significance. So you can accept the null hypothesis and reject the alternative hypothesis. Okay, so drawing down on an example again, page 361 in the textbook, do male and females, teens, drink different amounts of sports drink? So the null hypothesis in that is that there's no significant difference in the mean consumption of sports drink between males and females, or teen, probably I should have put in there, teen males and females. And the alternative, obviously, is that there is a significant difference in the mean consumption of sports drink between teen males and females. Okay, so drawing on that example and from the statistic they're actually provided in the textbook, the mean for the boys is 9, the mean for the girls is 7.5. They're both 100, the sample size was 100 for both, so it was probably a sample for 200 and they've just divided it. Maybe not. Standard deviation for the boys is 2 and the standard deviation for the girls is 1.2. So that shows the calculation there. We plug all of that in and we come up with a Z value of 6.43. Because the Z value is outside of 1.96 and minus 1.96, it means it's a statistically significant difference. So you can accept H1. So therefore, the difference in, so we've accepted the alternative hypothesis that there is a significant difference in the mean consumption of sports drink between males, brackets 9 bottles on average, and females, brackets 7.5 bottles on average. It is significant. So we can actually report a statistically significant result. Okay, so if you want to calculate this now, I've done one SPSS on this. I can go through further SPSS ones if we wish in a tutorial, but I just thought I might just do this one because in the end it's probably more useful in a tutorial format anyway. So the difference in the mean between the two independent groups, so this is what we've just been talking about, this is how we do it in SPSS. You select Analyse, Compare Means and Independent Samples t-test. Okay, then you select which variable you want to analyse and then allocate a grouping variable, for example, gender. Okay, so you click on Define Groups to allocate the values in the variable to Group 1 or Group 2. So you can see here I've clicked on gender is in blue there. I need to click on that little purple arrow that's pointing towards grouping variable. That will then put gender in brackets question mark, which means that it doesn't have its groups defined. You then have to click on Define Groups and go in and say use specified values. So Group 1 is 1, which I had already entered in. So 1 equals male in the group, and Group 2 is 2, which is 2 equals female in my database. So that's why I used those. So I could group it between male and female. I click Continue and then OK. And I get an output that looks like this. Okay, so that's the mean for each group. This is, so sorry, I probably didn't explain that. So that's P4 I chose. That's image 4, which is just a picture of cans that I asked people to rate in terms of how much they liked or disliked it. And the men liked it more than the females. So 2.73 was the average rating for the men. In fact, that's actually quite a low score because it's out of 5. So that's below average. So, but the females liked it even less than the males. But is that significant? When I'm reporting this to the Cairns Regional Council and saying it's interesting that you have men who like this more than women and maybe there's something in this, is there something in it, or is it just it still fall within the normal bounds of a normal of normal variation in samples? Okay, so that's the mean for each group. There is support for the null. There's support of the null hypothesis that there is little difference between the means because the significance is greater than 0.05. So the significance is the p-value, otherwise known as the p-value. The p-value or significance needs to be less than 0.05 to be significant. And if you look in the textbook at the example, and I deliberately did this, the textbook example actually has a 000 significance. So that actually supports the alternative hypothesis. So this is the other side of the equation. So I now know that there's not a significant difference between whether males and females like image for or not. It's a normal, just a variation in statistics, and it's not actually showing me that there's a significant difference there. So there's nothing for me to report on that. Okay, now we start thinking about significance again. So this is an ANOVA. So I've just talked about, here we go, differences in means between two groups. Okay, now we're going to talk about differences in means between 3 or more groups from independent samples. And that is, you use an ANOVA, an analysis of variance, calculation to analyse that. So used when comparing the means of 3 or more groups, ANOVA will flag when at least one pair of means has a statistically significant difference, but it doesn't say which pair. So you have to go and do further tests, but it flags which ones there are. So then you can go on, instead of having to test everything, you can just test the ones that show that there is a difference. Okay, now they call it a green flag. If at least one pair of means has a statistically significant difference, ANOVA will signal this by indicating significance, okay? So this is an output that I've just taken out of the textbook. Results of 5 independent samples t-tests of how likely customers are to return to make their next major purchase. Okay, also the automotive, electronics automotive, home and garden automotive, and sporting goods automotive. Oh, they're compared. Sorry, got it. So electronics versus automotive, the home and garden versus the automotive, and the sporting goods versus the automotive. It seems to me that the automotive seems to be different to everything else, and that's probably what I would take from that. They're the ones that have the significant difference between the two compared groups. Okay, so then you need to go in and do some more testing on that. To see. Okay, now like I say, we can go through that further in the tutorial, but that's just a bit of an overview, because ANOVA can get quite involved, and I thought it might be a little bit hard to follow, so it's probably better to do it in a tutorial, or in fact you can just explore it. Don't be afraid to just try these things and use your textbook and see what you can come up with using SPSS yourself. Okay, now I think this is my last slide. Yep, so there's finally the differences in means between two means within the same sample. So that's called a paired samples t-test, which is the significance of differences between means. So that determines if two means of two different questions using the same scale format and answered by the same respondents in the same sample are significantly different. I would use that to compare picture 1 and picture 2 in my sample. They were measured on the same scale, 1 to 5, and I can have a look and go, right, this is grouped here. So P1, picture 1 has got an average of 4, and picture 2 has an average of 4.3. Is there a statistically significant difference between them? I can go and do a paired sample t-test and have a look at whether there is a significant difference between whether people like those ones particularly or not. So then I can start working out where the major differences are. Rather than focusing on small differences, I can start thinking about major differences between different images. Anyway, I hope that's been helpful. I hope that keeping it sort of at a broader scale sort of gives you a better understanding of it without getting bogged down into detail. If you'd like some more detail, feel free to email me, and hopefully we can discuss it further in the Zoom tutorial, which you're welcome to attend. Okay, thank you.